Okay, now going down deeper, and I'll just give you a brief about how the authentications work between each component, a vBond, a vSmart, vManage, vEdge, etc. So authentication here, authenticating the vSmart and a vManage by the vBond. So the similar steps would be applicable for a vSmart or a vManage in this scenario. So for simplicity, let's start with that, hey, vBond wants to authenticate himself to the vSmart or the vManage. What are the steps that go into the backdoor? So the vBond would send his trusted root CA signed certificate. That means his signed certificate, vBond would actually send it over to the vSmart. He would also send a vEdge authorized serial number file onto the vSmart. After these two steps are done and the vSmart actually receives these two information, how will he authenticate that, hey, this vBond is the actual one which I am talking to? vSmart will look up the certificate which he has received from the vBond and extract the organization name from that certificate. So if this organization name matches with the one which the vSmart has by himself, so the vSmart would also have an org name defined. So if the vBond's certificate's org name matches with the vSmart's org name, that is the first or one of the levels of authentication that, hey, this is the right vBond, this seems to be the right vBond I'm talking to. Let me validate him further. That's the step 3. Now moving on, the last of the steps would be that verify that the certificate is signed by the root CA. So when he received this, when vSmart received the certificate from the vBond, the vSmart would like to verify that was this certificate actually signed by the root CA which it claims to be. So the vSmart would have his own root CA, and from the vBond certificate he received an entire certificate which is nothing but the message and the encrypted hash which is the root CA.
So on this page, what we're looking at is what does the authentication look like for vSmart as it's trying to validate the identity of vBond?
Yes, exactly. So yes, the last of the steps in that scenario is where the vSmart would look up his own root CA and he would try to, authenticate that the vBond's certificate root CA and my root CA is the same. That's the first part of it. So you can see that's the one-way DTLS connection, or that's only one half where vSmart or the vManage has authenticated the correct vBond. Now on the reverse side, authentication of the vSmart by the vBond. As you can see, the steps remain more or less the same. Here the vSmart would send his trusted root CA signed certificate over to the vBond. This is an important step where the vBond would verify the serial number of the vSmart. So like I mentioned before, vBond, vSmart, vManage. vManage has serial numbers, everybody has a serial number, but the information regarding these components, serial numbers, are stored by the vBond by itself. So these information, it's that way. So vSmart and vManage know about have to know the serial numbers of all the vSmart and all the vManages present in the topology, and the vBond would need to know all the vSmarts and all the vManages present in the topology. So vBond would already know that, hey, these are the serial numbers I should be expecting to connect to. So when a certificate comes in from a vSmart to a vBond, he looks up at the certificate's serial number. Again, by decrypting the certificate, he comes up that, hey, the certificate, the serial number that I have received from this certificate is 12345 ABC. Then he will look up at his own database and say, is this serial number supposed to connect to me? And if he says yes, like that is a tick mark, otherwise the connection is dropped at that point. Then the steps continue that, hey, let me verify the org name. Again, vBond would look up the vSmart certificate, figure out the org name. vBond would look up his own organization name. If these two match, then step 3 is a tick.
One quick question regarding the serial numbers.
Yes.
When vSmart and vManage send the serial numbers to vBond, do they do it individually, or do they advertise these serial numbers together?
Okay, so the provisioning of the serial numbers onto the vBond or onto all the control components, that is driven today by the vManage itself. So that's a chicken and egg problem, right? That vManage has not authenticated the vBond or the vSmart, but still the serial numbers have to be provisioned using the vManage. So to do that, on the user interface on the vManage, you need to add the vBonds and add the vSmarts manually, like type in their out-of-band IP addresses. So when you add these, they are not authenticated at this step. You are just giving their out-of-band IPs where the vManage can go and connect to these, via an SSH or something like that. When the vManage connects to these entities, the serial number information is extracted and populated in the database of the vManage. So vManage or vSmart, they don't care about what the vBond's serial number is. Serial number of the vManage itself, serial number of all the vSmarts, say for simplicity we have one vSmart. These two are an important criteria to be propagated. So vManage would learn number 2, he would know number 1 by himself, and these information would be propagated among all 3. So that's how, using an out-of-band reachability, you will be populating the databases that, hey, expect these serial numbers to come in.
Sure.
So what you're describing between the two is, one is a provisioning behavior,
Correct,
where you're describing vManage, vBond, vSmart, and how you propagate the serial number list,
Exactly,
as opposed to how the serial number is actually used when we're establishing the control connection.
Exactly, yes. So this is the provisioning part of it. Once you have provisioned, that means the serial numbers are present onto the respective entities, and then the authentication mechanism, like Ali said, takes place.
So I have another question.
Yes.
So if I understand it right, basically the vBond and vSmart exchange certificates trusted by a root CA,
Exactly,
to ensure that they are the authentic ones, right? And then the serial number kind of ensures that this kind of like allowed to communicate with that vSmart.
correct, like a certificate revocation list.
Yes, whitelist or anything you would call it,
Yes,
just to make sure that he's allowed to communicate.
exactly.
Right? And what is the function of organization name at that point? Because they know each other at that point and they know they should be talking to each other, right? What is the function of organization name in that case to verify organization name?
Okay, that's a good one. So organization name would matter because you can have different organization names coming and talking to different entities. So an organization, say A, would try to talk to an org B's vBond, and suppose org B's vBond, for some reason, for some, let's say a manual error or something, had propagated organization A's serial number in it. So the org name by itself would be another level of authentication. It might be, it's not a redundant step, but as it is a security layer, the more authentic you try to be, the more it helps. And also the organization name comes in handy when there's a multi-tenant story into the picture. That's also when the organization name is important as such.
Another question about organization names. Can I use any organization name, or is there a specific criteria that is allowed and not allowed?
Okay, that's a good question. Ali, can you share some light on his question specifically around the legal limitations and the bounds on what an organization name should be?
Certainly. Organization names for certificates are tied to legal entities and legal corporations. So you cannot choose any arbitrary name that you want. These have to be tied to either alphanumeric strings, they cannot have special characters, and they must be either completely gibberish or they must be tied to registered entities with which you, as an identity that you can claim. So if you are a particular bank and you are registered to do business in, say, the United States as that bank, only will then the root of trust issue you a certificate using that name. I, as Cisco, cannot get a certificate claiming to be Bank X within the United States. So there are some very specific legal restrictions on the type of things that you can put into organization names.
Thank you, Ali.
Okay, thank you. So yes, those were the restrictions, the limitations around the organization name. So that completes the authentication part of the vSmart vManage, vSmart/vManage by the vBond. So after this, there's a permanent DTLS connection between these entities. That's between a vSmart and a vBond, or a vManage and a vBond. Okay, moving on. How does authentication work between vSmarts by themselves? So there can be many vSmarts in an organization or in a topology. So how do these vSmarts authenticate each other? Again, the steps would be more or less similar. I'll just want to skim through it. So the vSmart 1 sends his signed certificate, which is signed by some trusted root CA, to vSmart 2. vSmart 2 knows the serial numbers which were propagated in the provisioning part of it. So serial numbers are exchanged in this way. vSmart 2 would know that, hey, there is vSmart 1 which is trying to connect and is a serial number a valid serial number which is present in my database. Then he would verify the organization name, again by the similar steps, looking at vSmart 1's certificate organization name and vSmart 2 by himself, his own organization name. And finally verifying that the certificate is actually signed by the root cert. So he would have his own root CA, he would look up vSmart 2 would look up vSmart 1's certificate and validate if it was actually signed by the root CA which it claims to be.
One quick question regarding the authentication and validation between the control elements.
Okay.
Is there a server hello, client hello? Who's always the server and who's the client?
Okay, so yes, that's a good question. Again, between vSmarts specifically, the lower system IP is always the client and the higher system IP is always the server. So let me put it that way. System IP is one of the parameters which uniquely identifies a device by itself. So a system IP is present for all of the SD-WAN components. That's a vSmart, a vBond, a vManage, or a vEdge, or a cEdge. So between controllers, system IP is the parameter which is looked upon to decide which should act as a client, which should act as a server, and stuff like that. Then when it comes between the edges and the controllers, the edge device would always act as the client and the controllers would always act as the servers.
So the vBond would always be the server?
Yes, exactly. vBond would among the control and orchestrator components, vBond is always the server. So vBond is, the go-to guy where every component has to go and connect to first. So the vBond information has to be present on all the entities. Like, how would vSmart 1 know which vBond to talk to? vSmart 1 should have, in his configuration by itself that, hey, my vBond is x.vBond or some IP address which is provisioned, prior to getting the certificate stored into the picture. Okay, so yes, that's the one-way SSL connection after these 4 steps have gone through, and the reverse is true when vSmart 1 wants to authenticate vSmart 2. So these are the steps which are exact replica of the first phase of it.
So in every communication, it's mutual authentication.
Exactly, yes. In every communication, there is a two-way or dual authentication. It's not that, hey, I've authenticated you, so it's not the reverse way always, that if I authenticate you, that means you have authenticated me. No. always the dual authentication or the two-way handshake has to be present in the SD-WAN story out here.